Hello class, today I'm going to be going through a step-by-step guide on how to prove that line BC is congruent to line DF. To do this, we'll first have to prove that they're triangles, but that is a little bit later down this. The first thing that I like to do when I'm trying to prove that two triangles are equivalent to each other is write down these boxes, and you use these in the end to prove that they're equivalent. So SSS means that that three sides of each triangle are equivalent to the other sides in the triangle. Congruent to the other sides in the triangle. SAS means that one angle and two sides are congruent in each triangle. ASA means that one angle, two angles, and one side are congruent to each other in the triangle. And AAS means that two angles and one side are congruent to each other. And last but not least, hypotenuse lengths are equivalent. This only works if you have right triangles, and we'll have to figure that out if that's true down the road. So first thing you're going to want to do for your statements right here is put down your givens. So the first given is that line DE right here and line AB right here, they're parallel. So you're going to put that these two are parallel. And then write it down over here. Like so. Second thing you're going to do is that line AF is congruent to line CE. So right here, CE congruent to AF, that will come in handy down the road, since you can't determine any of the sides are equivalent right now from that. Next step is that line AE is perpendicular to line BC. Right there, line AE, BC perpendicular, line AE, DF perpendicular. And same with lines AE and EF. Now,
CB. No, DF.
that's not right.
DF.
DF. Sorry about that delay. Try and make up with time. And that is a given. And that takes care of our givens. So for step 5, step 5 is we're gonna say that angle A is congruent to angle E. So we're saying that these two angles are congruent. Now remember that these lines are parallel and this would be a transversal line. So our proof or reason is going to be that angle A and angle E are alternate interior angles, and these are two parallel lines cut by a transversal, which means that alternate interior angles, meaning they're on the inside of both parallel and on the opposite lines of the transversal, are congruent. So we're going to write for our given, right after I can write 5, write for our given two parallel lines, using short form if you like, cut by a trans line implies that alternate interior angles are congruent. Step 6, our statement's going to be that angle C right there. So we can actually, I forgot this real quick, got a marking that those two are congruent. That means we actually have one angle in the triangle right here.
And you can cross off.
So now I can cross that off. And I'm not going to cross any of these off yet. Step 6, I'm going to say that angle C and angle F are right angles. And the reason behind this is that they're perpendicular to line EA, both these lines. So then the angle that they create, because perpendicular lines imply that there are right angles, that means that they're both right angles because they're perpendicular. So our short form reason is going to be perpendicular lines imply that right angles are present. And we can't mark off any angles or sides with this yet. But with step 7 is going to be the one that we're going to prove that angle C is congruent to angle F. And our reasoning behind that is because angle C and angle F, they're both right angles. And right angles equal 90 degrees, and 90 degrees equals 90 degrees. So our reason is just going to be a symbol. I know it sounds funny, but you have to include this in your step. Right angles are congruent. And with that, I'm going to hand it off to Wesley to finish this up. Sorry, I just quickly have to say, we're going to go over here, do another angle, which can eliminate this because there's two sides, and we can also eliminate hypotenuse length because it's if you have the length of a leg and the length of the hypotenuse and it's a 90 degree, that's how you get that. But we already have two angles, so that can't happen.
Wait, hold on. Quick pause. Just keep recording. Okay, so now we're going to continue with this problem. So where we left off, we have so far proven that angle C and angle F are congruent, as well as angle A and angle E, which leaves us with either angle side angle or angle angle side. So we're going to hop right into step number 8, which is going to be proving that right here, A plus F, AF plus FC equals AC, as well as FC plus CE equals FE. And the reason we know that is the segment addition postulate. And basically what the segment addition postulate states is that if you have 2 points that make up a line segment, in one of the cases A and C, as well as a third point that is on the same line, then the 1 point on the end plus the point in the center, as well as the point in the center plus the one on the other end, would equal the beginning and end of the segment. And the same would go for FE. And so now we're going to go down to step number 9, which we're going to go ahead and say that FC is congruent to FC. And I know that sounds ridiculous, a line being the same exact length of itself. However, you need to have that. And the reason for that is going to be the reflexive property. Now we're going to go down into step 10, which is going to be saying that AF plus FC is congruent to CE plus FC. And the reason we know this is again going to be the segment addition postulate. As we can see here, EC is congruent to AF, so they're the same value, and they're both being added to the same value. So a good way to exemplify this would be if AF is 1, then CE is also 1, and if FC is 2, then 1 plus 2 equals 1 plus 2. Now we're going to go down into step number 11, which is going to tell us that AC is congruent to FE. And this is through substitution. And the reason is, if we know that AF plus FC is congruent to CE plus FC, and we know that AF plus FC is congruent to AC, and FC plus CE is congruent to FE, then we know that AC is congruent to FE. And this will give us our line that we need, which is AC is congruent to FE, which would give us another side, and which would end up giving us angle, side, angle, because there is a side that is touching two angles, which is different than angle, angle, side.
Write down the step of a triangle equal triangle. Write down triangle equal triangle.
So now we're going to go into step number 12, which is going to be proving that triangle ABC is congruent to triangle EDF. And we know this because when angle, side angle is congruent to corresponding angle, side angle, that implies that we have congruent triangles. And into step 13, to solve our original problem, prove that that line segment BC is congruent to line segment DF, we're going to say that line segment BC is congruent to line segment DF. And the reason for this is going to be, if we have congruent triangles, this implies that corresponding sides are congruent. And this is a 13-step proof of BC being congruent to DF.